4 sections out of chapter 11. This chapter will go pretty fast, but not as fast as it normally would if we were doing 2 sections every day. We are going to do only 1 section each day because they're pretty packed full of information, except this first section. It's pretty easy, okay? This first section, you should already know most everything in this section, but I'm going to remind you and help you with some picky things just to make sure it doesn't catch you. Before we get started, though, in Chapter 11, at any point, if you are a hands-on visual learner and you need to feel it, see it, touch it, draw on it, in my little podium back here, there are 3 drawers down here at the bottom full of 3-dimensional solids. You can take those solids, you can grab an Expo marker, please make sure it's not a Sharpie. Grab an Expo marker, you can draw all over the shape. It erases right off, just erase it when you're done. If you're in here in Encore, before school, after school, and you need to physically draw on it to see it, you're more than welcome to come grab one and use a marker and draw on it. They're sitting up here today. I'm going to talk about all of them today, but then if they're put away, just come up and grab what you want, okay? For some of you, that'll be really helpful. You'll notice that some of them have strings. We're going to be talking about these that come to a point. The hardest lesson in Chapter 11 will be 11.3, which will be next Wednesday. Do I have anybody in here who is in the play? Okay, both of you before you leave today need to get the assignments for Wednesday and Friday because you're going to be out both days. And you make sure you watch the video. You are more than welcome if you would like to come in on Thursday during 5th period if you can. I'll be teaching that lesson to my 5th period pre-AP class. Highly encourage you to do that if you can. I'll also be teaching at 6th and 7th periods on Thursday to regular geometry, but it'll be the same content, so if that's helpful to come in one of those periods. Otherwise, watch the video because there's a lot of stuff in it that's super important, but it's the hardest lesson, okay? So next Wednesday when we get to this, make sure that you are paying close attention. We'll be talking about what these strings are all about today so you'll understand it better for Wednesday. The other thing I want to warn you are freshmen and sophomores. The play is next Friday for you. If you choose to go in the morning to the play, you will miss section 11.4. I am teaching it whether I have 2 people in here or 25 people in here because we just don't have any more time. So my advice would be switch and go to the afternoon performance on Wednesday if you can. If you can't and you have to miss Friday, you need to get your assignment ahead of time. It will be due on Tuesday with everyone else, and it's over 11.4 and it's over spheres. Okay, so think about that. You can switch and go to the performance in the afternoon, but it's on Wednesday, not Friday. They're switching it this year. Juniors and seniors will go on Wednesday afternoon. Freshmen and sophomores are going on Friday morning. Is everybody clear about the play? Okay. All right, so we're talking solids. You know where to find them. I'm going to go through this pretty quickly. Stop me, though, if you're lost, because some of this I just assume you've seen before, and some of it you may not have seen before. Lots of vocab. Did I say there's a vocab test? Yes. And a formula test? Yes. Okay. So when we get to formulas, which are not today, we'll make a list of formulas like we did last time. All right. 3-dimensional figures are called solids. They can be made up of flat or curved surfaces. The flat surfaces are called the faces. There are going to be some things I say today that are not written on your notes. Feel free to write them down, take notes. But some important things. So first of all, how many faces does this shape have? 6. Okay, when we talk about faces, we're going to talk about 2 different kinds of faces. We're going to talk about the faces that are lateral. The lateral faces are going to be the faces that are not the bases. When we're talking about the bases, we're talking about the 2 shapes that are parallel and congruent. When you look at this shape, no matter how I turn it, whether it's sitting like this or sitting like this, what are the 2 shapes that are congruent and parallel from all the other shapes? So what are the 2 congruent parallel shapes in this solid? Squares, the top and the bottom. Are you guys with me? These would be called the bases, but even if it's sitting like this, it's not always the bottom that's the base. The left side and the right side are the bases. The bases, by definition today, are going to be the 2 shapes that are congruent and parallel. Even though you have 2 congruent parallel rectangles, You really have 4 congruent parallel, 2 sets of parallel rectangles. So the 4 rectangles that are the same are the lateral faces. That's not written anywhere in your notes. You may want to write that word down. Lateral faces, and then the other 2 are the bases. Okay? Next section, we'll talk about the difference between surface area and lateral area. The lateral area would be the area of the 4 rectangles. Surface area would include everything. You guys with me so far? Okay. What is this shape called? It is not a rectangular prism. What is this shape called? Square prism. The way you name a prism is by the 2 parallel congruent bases. And the bases here are squares, not rectangles. The rectangles are the lateral faces. What is this shape? Triangular prism. Every year I have students get confused on this one because if it's sitting like this, they want to think the base is a rectangle. The base is not a rectangle. You do not have another parallel rectangle to it. You have 3 rectangles that are congruent to each other, and you have 2 parallel triangles. So this is a triangular prism. Be very careful about that. All right, edges. Edges are going to be where your 2 faces meet. So how many edges do I have on this shape? Agreed, 8. We've got 4 along the base, and then we have 4 edges going up to meet the point, right? So 8 edges. Edges are going to be line segments, so when you name them, you're going to name them just like chapter 1 with line segments. A vertex. Vertex is going to be where 3 or more of your faces meet. So where 3 or more meet. How many vertices would this shape have? 5. We've got 1, 2, 3, 4 along the base, and 1 at the top, 5. Be very careful. How many vertices does this shape have? Only 1. This little point on the bottom is the center of the base, but it is not a vertex. What is that shape? Cone. All right, moving on. We are going to, it's all right. We're going to group these together to memorize less formulas as we move through the chapter. So in section 11.2, we're going to focus on just the prisms and the cylinders. And we're going to group them together because they're the 2 shapes that have 2 parallel bases. And then on Wednesday, we're going to talk about the pyramids and the cones together. We're going to group those together because they come to a point and they only have 1 base. Prism is different than a cylinder in only the fact that the cylinder has a circular base. The prism has a polygonal base. A polygon is not a circle, so be careful. So prisms are going to have parallel bases. Every one of the lateral faces are going to be parallelograms. They look like they're what shape here? Rectangles. And they'll be rectangles as long as the prism is not slanted. We're going to look at slanted prisms and talk about what those are called. But as long as the prism is a right prism, those will be rectangles. If they're slanted, they'll be parallelograms. Cylinder has 2 circular bases and the rest of it is a curved surface. Pyramids come to a point and have 1 base, and again, they can be slanted. And then a cone has a circular base and comes to a point as well. Any questions about definitions, difference? Cube, I'm going to have you challenge you guys not to use the word cube. I want you to use the actual term for the word cube, and that is a hexahedron. Add this to your notes. Hexahedron. That is the formal term for a cube. Hexahedron. A hexahedron is a cube. A cube has 6 square faces. That means any 2 of the parallel squares would be considered the bases. Any 2. It doesn't matter which 2. Just pick 2. Those would be your bases. The other 4 would be your lateral faces because they are all congruent to each other. You are going to be asked to name the solids correctly. So be careful. Prisms have 2 parallel bases. Pyramids have only 1 base. We're going to be looking at nets today too. You are going to have to draw nets and you are going to have to draw three-dimensional solids. When you're looking at a net, it is very obvious on the net. JP, you with me? Stay with me. Heads up. It's going to be very obvious when you're looking at the two nets which one's a pyramid and which one's a prism by looking at the lateral faces. If you're looking at the lateral faces, they should be what shapes? Rectangles or parallelograms if they're slanted. When you're looking at a pyramid, what are their lateral faces? Triangles. Back here, I didn't point that out in the definition, but if you look here, the pyramid has triangular faces. The prism has parallelograms for faces. So when you're looking at the nets, that'll be very obvious. Which one of these is going to be a pyramid, blue or green? Green, because it has triangular faces. The blue one has rectangular faces. These are going to be your lateral faces, and the two shapes that are, when folded, parallel to each other, those are going to be your bases. So what will this fold to be? Pentagonal prism. What is this going to fold to be? It's not a triangular pyramid. What's your shape in the middle? A square. That's going to be your base. So when you fold it up, the base is a square. It's always going to have triangles in a pyramid because those have to fold to make the point. It's what do you have on the bottom that you name it as. So be really careful when you're looking at those nets that you can name them correctly. Are we good so far? Okay. I want you to go through, you and your partner, and answer the next, let's see, one. Try to go all the way through to where it says cross-section. So answer every single thing until you get to cross-section. Okay? Go. I'm going to give you a little bit of time. First one together just to set you up for success. What is this figure? Hexahedron. I'm going to tell you that in the textbook, they're not always very clear to mark the pictures, and you may look at this and say, I don't think it's a hexahedron. I think this looks like it's a different size than the top. Maybe it looks like a square prism to you. How many people think the top and bottom look like they're different than the four around the middle? Okay. If you did, if you thought it was a square prism, I would accept that. If you say hexahedron, I'll accept that in the book until they mark something that identifies. Like if they went around and did this, then I would say you know it's a hexahedron because everything's marked congruent and right angles. If they don't and you think it looks more like a square prism or a rectangular prism, then I'll accept those answers, okay? So classify it. Next thing they want you to do is list the vertices. Vertices are the points, and when you list them, you have to separate them with commas. Don't just write them in order. So how many vertices do we have here? 8. It didn't say list the number, Sean. Make sure you're with me. It did not say how many vertices does it have. It says name them. Name them means list the vertices. So when you write your answer, it is not that there are 8 vertices. It is A, comma, B, comma, C, comma, D, comma. You have to write them all out. Are you with me there? Okay, how many edges is it going to have? 12. 4 on the top, 4 on the bottom, 4 vertically. When you name an edge, you have to name it as a line segment. It has a segment above it. Make sure you separate those by commas. So it should be AB, BC, CD, DA, then do the ones on the bottom, do the ones vertically. Are you guys with me? This is tedious on the homework. You've got to write them all out. But make sure you're separating them individually, each line segment, and listing them. It said to name them. And then lastly, if you say it's a hexahedron, you could pick any 2 bases. If you say it's a square prism, then you have to name the 2 squares that you see. Pick 2, only 2 to name as your basis. So there's 6 possibilities if it's a hexahedron, but just pick 2 of them that are parallel. So I could pick A, B, C, D, and E, F, G, H, and not name the rest of them. Those two would be my bases. Does that make sense? And to name a shape, remember you're going consecutively clockwise around it. You do not put anything above it. Separate it with a comma after you name each shape. Okay, keep going. Go all the way to where it says cross section. Okay, I'm going to pull you back. I didn't really go over everything to make that fully clear on parts of it, so we'll come back and look at some of that in just a second. But first, what shape is this? Classify means to name it, so you have to name the shape. What is it? Pentagonal pyramid. Pyramids come to a point. Prisms have two parallel bases. So you should have said pentagonal pyramid. Some teachers say pentagonal pyramid or hexagonal pyramid. I can't do it. I was always taught pentagonal, so that's what I say. Vertices. How many vertices does it have? 6. Make sure you listed all of those with commas in between. A, B, C, D, E, F. How many edges is it going to have? 10. It's going to have 5 around the bottom and then 5 coming up slanted to the top. So you should have named 10 line segments. That's the tedious part. Make sure you are putting line segments above them. As I was going around, I was trying to catch that and remind you. Bases. How many bases does it have? Just one, the pentagon. So when you name that, make sure you name those consecutively with no commas. So start anywhere you want, but then it's A, B, C, D, E as you go around. Any questions there? Okay, look at the next one. What shape do we have here? A cone. So when it says classify, that should be cone. How many vertices does a cone have? Only one. Just that point in. That is its vertex. How many edges does a cone have? None. There are no faces that come together to create a line segment. This is circular here, and this is all curved around it. So there are no edges. What about bases? There's one base, and I didn't see very many people name it correctly. We briefly mentioned it last chapter in the notes. To name a circle, you do not just put a letter. That would be a vertex. You have to put a circle with a dot in the middle, and then you name it by the center. So this base is circle M. Okay? Don't just put a letter. Any questions there? Okay, net. I didn't talk a whole lot about the net. So, first of all, your net is two-dimensional. Add that to your notes. Your net is a two-dimensional representation of a three-dimensional solid, and I have a bunch of nets up here. So if you need a net, if you need to look at it physically and fold it and see what does it really fold into, you are more than welcome to come get them out of the drawers and play with them. Just be careful with them, please. Obviously, you can see where somebody was not very nice to this one, and so now it's got the little sad tape marks where it's been cracked. They're pretty pricey for a simple little plastic object like this, so please be careful if you are messing with them. All right, so your nets. I already said this once. Big way to tell what kind of shape it is does your net have rectangles, parallelograms, or triangles? If it's made up of triangles, it's going to fold in order to be a pyramid or a cone. If it's got rectangles, it's going to fold to be a prism or a cylinder. If it has circles, it's going to be cylinders or cones. So when we look at our net, and by the way, you're going to have to draw nets and draw three-dimensional shapes. So if you need help, look in your book, Google what's the net of a hexagonal prism, and then help yourself out until you get really good at it before the test. What would this shape be? Hexahedron. It has all squares, so it's going to be a hexahedron. The book's going to say cube. We're going to write hexahedron. That is a cube. Okay, what's the next one? Cone. I want to talk about this real quick because this is going to be super helpful for later. On your cone, Notice there's no triangles, but you've got this curved section and a circle and only one circle, so that has to be a cone. It can't be a cylinder unless it has two circles. On your cone, what is this going to be the same as? The circumference of your base, right? When I fold this up, that matches with our base. So this is the circumference of the base. Okay, super important. You may want to make a note there. Here is the hardest part of chapter 11, and I don't know how much of this you guys did in middle school. There are two different kinds of heights in chapter 11. There is the H height, which is the height of your prism. If I look at my prism, this is my height, perpendicular to the base. Notice the red string would be your height. Does everybody see the red string's the height? Or this edge could be my height in a prism. That is not true for a pyramid. Be very careful. In your pyramid, this red string is still your H height. But this edge is not the height. Would you agree? It's slanted. This is just an edge. In your pyramids, they're going to have what are called slant heights or lateral heights. Slant height is why we have these red strings. When you slide it over, notice that you have a slanted height of one of your triangular faces. Do you see how that is the height of a face? That's called the slant height. They're going to use the letter L for that because it stands for lateral height. There is an L height and an H height. Same thing for the cone. What would this red string represent right now? H height. What would the red string represent now? The L slant height. Okay? So be really careful there. When I'm looking at my net, what is the distance from the center to the edge here? Guys, look up here at me. What's the distance from here to here gonna be? Is this distance from here to here gonna be H height or L slant height? Slant height. When you fold it up, do you see how that becomes the slanted height? So in my picture here, from the center down to here will be L, which is our slant height or lateral height. You can write it either way. Slant height or lateral height is the letter L. Everybody okay with that? Hardest part in chapter 11 is going to be finding the difference between H and L and calculating those. So to help you out a little bit, what do you notice that your H height, look up here with me, what do you notice that your H height and your L slant height make? Does everybody see the right triangle being formed? Do you see this right triangle formed by this piece here? So you're going to be dealing a lot with right triangles, either Pythagorean theorem, special right triangles, or SOHCAHTOA to calculate the H height or the L slant height in these shapes. And that's why 11.3, when you get the pyramids and the cones, become the harder sections. Because the prisms and cylinders just have an H height. They don't have a slant height, so they're easier. Okay? All right, just kind of setting the stage for those harder sections. What is this shape? Triangular pyramid. Make sure you can spell the words correctly, name them correctly. What is this? Cylinder, has two circular bases. All right, last thing for today is cross sections. Stay with me, I know you're tired. Cross section, if you get stuck on a cross section, go home, get some Play-Doh. If you have Play-Doh, make yourself a shape. Make yourself a cone. Take a knife, or if you want to be a little less scary, take some dental floss and slice your Play-Doh. That's going to create a cross section. Cross section, by definition, is going to be a 1 or 2 dimensional shape. And I'll show you in a second why it could be 1 dimensional. 1 or 2 dimensional shape that is formed. Actually, it could have no dimensions technically. So I guess I should say it's 0, 1, or 2 dimensional, because technically it could have no dimension. But it is the intersection of a plane and a shape. So the very first question that you'll see here would be an example of me holding a cone and this being my plane, my knife, my dental floss. If I set it on top of the cone, what is the intersection shape that they have in common? A point. A point is no dimensional. It has no size. It's infinitely small. So the geometry shape that represents the cross section is just a point. So when you get to the homework, it's going to say describe the cross section. Describe just means name the shape. It's a point, it's a triangle, it's a line. What is the cross section? Okay? So look at the next one. What's the cross section here? Pentagon. If I take a sphere, like an orange, and I slice my orange in half, what's the two-dimensional shape that you're going to see? A circle. So your cross section is the shape you get when you slice your object and open it up and look at it. What do you see when you open it up? So if I were to take this shape and I slice it, I end up with a pentagon. Now be careful. The other part of the homework is they're going to ask you, how should you slice it? JP, do you need to stand at the back? Okay, you're sleeping a lot, bud. It's going to hurt you. This is the easy part, but you need to make sure you understand. The other part of the homework is it's going to ask you, how should you cut it? So they may say, if I want to get a pentagon and I have a pentagonal pyramid, how should I cut it so that I get a pentagon? You cannot say horizontal or vertical. And here's why. Very good. If I take my shape and hold it like this, and you said horizontal, and I slice it horizontal, I'm not going to get a pentagon anymore, right? So you have to describe your cut in reference to your base. So how do we want to slice this so that we get a pentagon? Parallel to the base. You're going to use those two phrases, parallel to the base or perpendicular to the base. Okay? All right, next one. What do I get here for my cross section? Hexagon. The next two questions, or actually, is this the last one here? Oh, yeah. So what do we have here? What's our cross section? Triangle. Okay. The next two questions are going to ask you to describe how you should cut the cheese. How you should slice the cheese. So look at this problem. They gave you pictures. They're not going to always give you a picture. So make sure that you can draw a picture. You want a equilateral, triangular prism. Okay? You have a picture on your paper, but if you have to draw it, one way I do it is just draw the base first and then make it a prism. You're going to use dashes for the parts that you can't see to show that third dimension. Okay? So make sure you can draw these shapes or look in your book or Google if you need to until you get good at it. But if you want this, you want to end up with a cross section that's an equilateral triangle. How are you going to cut the cheese? How are you going to cut it? Parallel to the base, perpendicular to the base? Parallel to the base. So your answer in a complete sentence should be, oops, cut parallel to the base. Okay? If you look at the next one, you want to get a rectangle. How are you going to cut the cheese so that you end up with a rectangle? Perpendicular to the base. Yes. So if you want to end up with the base is, you cut it parallel to the base. If you don't want to end up with what the base is, then you're going to cut it differently. It may be perpendicular to the base, or look at the last one. It's the hardest. And it's the hardest because your words would have to describe it to make sense. So there really are cube-shaped watermelons. They grow them in boxes to make them easy to ship. Oftentimes in Japan, they grow their watermelons as cube-shaped because they're awesome. So how would we cut this watermelon so that we get a triangular shape? Diagonally like this. Oops. I'm trying to do what I'm trying to say. So diagonally like this. Okay, so diagonally is not a good enough description because that's a rectangle. How do I cut it to get a triangle? Say it again. Diagonal to the vertex. How would that help me know where to start? Be more specific. What are those called? They're not sides. Edges, okay? So if we went an equal distance from a vertex on how many edges? So if I just go to 2, that's not going to be enough to cut a cross section. So I need to go how many different directions? 3. So if I went equal distances from a vertex on the edges, on 3 consecutive edges maybe, and then cut, as Hallie or Rachel said, diagonally, would that cut off a triangle? Okay, so we would have to use our words and describe it very detailed. That's the hardest part. So they said, cut through the midpoints of 3 edges that meet at a vertex. Doesn't have to be the midpoints though, right? But that's an easy way to describe it. They would just have to be an equal distance from the vertex. So you could say go out an equal distance from the vertex on 3 consecutive edges and slice it diagonally. And that's what we basically said. You probably won't have any that are this difficult, but you might have some where you have to think a little bit. It wouldn't have to be an equal distance either. That's just an easy way to describe it. But you would need to slice diagonally through 3 consecutive edges that share a common vertex. And that would still work. Okay, guys, questions? All right, you got about 15 minutes. Use it to get as much of this done as you can. Last hour, they only had 15 minutes, and one person got it completely done. Of course, it was regular, and their assignment's a little shorter than yours. But not that much today. This one's easy. It's pretty short.